Hello students, let us see the mini test questions on the topic real numbers. Section A, question number 1. The LCM of 2 power 5 into 3 into 5 and 2 power 2 into 7 into 5 is, the options are 140, 320, 1360 and 3360. To find the LCM, we have to take the highest powers. So, LCM equals 2 power 5 into 3 into 5 into 7, which equals 3360. So, the answer is option D, 3360. Question number 2. The sum of exponents of prime factors in the prime factorization of 1764 is, the options are 3, 4, 5 and 6. The prime factorization of 1764 equals 2 power 2 into 3 power 2 into 7 power 2. Now add the exponents. So we get 2 plus 2 plus 2 is equal to 6. So the answer is option D, 6. Question number 3. If HCF of 336 and 54 equals 6, LCM of 336 and 54 is, the options are 2024, 1012, 3024 and 1512. We need to find the LCM. So by using LCM into HCF equals product of two numbers, we get the LCM as 3024. So the answer is option C, 3024. Question number 4. If n is a natural number, then which of the following numbers end with 0? The options are option A, 3 into 2 power n, option B, 2 into 5 power n, option C, 2 into 6 power n, option D, 3 into 5 power n. A number ends with 0 only when it has factors 2 and 5. So the answer is option B, 2 into 5 power n. Question number 5. If a power b equals 32, where a and b are positive integers, then the value of b power ab is, the options are 5 power 10, 72, 2 power 10 and 5 power 12. First, convert 32 into an exponent. We get 32 equals 2 power 5. So we can say that a is 2 and b is 5. Now find ab, that is 2 into 5, which equals 10. Now find b power ab. So b power ab will be 5 power 10. So the answer is option A, 5 power 10. Question number 6. The smallest irrational number by which square root of 20 should be multiplied so as to get a rational number is. The options are square root of 20, square root of 2, 5 and square root of 5. If square root of 20 is multiplied by square root of 5, we get square root of 100. Square root of 100 can be written as 10. 10 is a rational number. So our answer is option D, square root of 5. Question number 7. The greatest number which divides 70 and 125, leaving remainder 5 and 8 respectively is, the options are 13, 65, 875, 1750. First, we need to subtract 5 from 70 and 8 from 125. So we get 70 minus 5 is equal to 65. 125 minus 8 equal to 117. Now we need to find the HCF. So the HCF is 13. Hence the answer is option A, 13. Question number 8. Assertion. If HCF of 510 and 92 is 2 and their LCM is 32,460. Reason. HCF of AB into LCM of AB equals A into B. First, we need to check whether the assertion is true. Finding the HCF of 510 and 92, we get 2. So, that is correct. Now, find LCM. LCM of 510 and 92 is 23,460, but the given LCM is 32,460, which is wrong. From this, we can say that assertion is false. Now find whether the reason is correct. HCF of AB into LCM of AB equals the product of the numbers, that is A into B. So the given reason is correct. Hence the answer is option D. A is false but R is true. Section B, question number 9. Explain why 7 into 13 into 11 plus 11 and 7 into 6 into 5 into 4 into 3 into 2 into 1 plus 3 are composite numbers. A number is considered composite if it has 2 or more than 2 factors. So, we need to show that the given 2 expression can be written as 2 or more than 2 factors. Let us consider the first expression, that is 7 into 13 into 11 plus 11. By taking the number 11 as common, we get 11 into 7 into 13 plus 1. By simplifying, we get 11 into 92. So this expression can be written as 11 into 2, which has 2 factors. Now, considering the second expression, that is 7 into 6 into 5 into 4 into 3 into 2 into 1 plus 3. Here, considering 3 as common, then the expression becomes 3 into 7 into 6 into 5 into 4 into 2 into 1 plus 1. After simplifying, we get 3 into 1681. So this expression is also written as the product of 2 factors. So the conclusion is both are composite numbers. Question number 10. Find the greatest 3-digit number which is divisible by 18, 24 and 36. Since it is finding the greatest 3-digit number that should be divisible by 18, 24 and 36, we have to find the LCM of these 3 numbers. So finding the LCM, we have to take the highest powers. So 18 is written as 2 into 3 power 2, 24 is written as 2 power 3 into 3, 36 is written as 2 power 2 into 3 power 2. So the LCM is 2 power 3 into 3 power 2, which equals 72. Now we need to find the greatest 3-digit multiple of 72. For that, divide the greatest 3-digit number by 72, that is 999 divided by 72. Approximately we get 13.875. So consider the whole number 13. Now multiply this 72 and 13, we get 936. So 936 is the greatest 3-digit number which is divisible by 18, 24 and 36. Section C, question number 11. Prove that square root of 2 is an irrational number. Assume that square root of 2 is a rational number. So square root of 2 can be written in a p by q form, that is square root of 2 equals p by q, where p and q are co-primes and q not equal to 0. Rearranging the equation, we get p equal to square root of 2 into q. Now square on both sides, then we will get p square equal to 2q square. From this we can say that p square is divisible by 2. So that p is also divisible by 2. Therefore, p can be written as 2 into r, where r is some integer. So substitute this in the previous equation, we get 4r square equals 2q square. On simplifying, we get 2r square equals q square. That is, q square is divisible by 2, so that q is also divisible by 2. Hence, p and q are not co-primes. But this is a contradiction that our initial assumption is p and q are co-prime. So that we can say square root of 2 is an irrational number. Section D, question number 12, part A. 3 bells toll at intervals of 9, 12 and 15 minutes respectively. If they start tolling together, after what time will they next toll together? For this, we have to find the LCM. Find the LCM for 9, 12 and 15. We get the LCM as 180, and that is 180 minutes, and the minutes is converted into hours, which is 3 hours. So they will toll together after 3 hours. Now part B. Given that square root of 3 is an irrational number, prove that 5 plus 2 into square root of 3 is an irrational number. Let us assume 5 plus 2 into square root of 3 is rational. That is, 5 plus 2 into square root of 3 can be written as p by q, where p and q are coprimes and q not equal to 0. By rearranging, we get 2 into root 3 equals p by q minus 5, which implies square root of 3 equals p by q minus 5 by 2. Since p, q and 5 and 2 are the integers, we can say that p by q minus 5 by 2 is a rational number. But given that square root of 3 is irrational, a irrational number cannot be equal to rational number. So this is a contradiction, so that we can say 5 plus 2 into square root of 3 is irrational. Thank you students. Thanks for watching.